Welcome back to Graylog Go. Again, my name is Nick Carstensen, in case you missed the first presentation. I wanted to thank everybody so far today that has been coming up here, giving their presentations. It's been really enjoyable listening to everybody. We have great feedback from our audience. So this one is a little more technical of a presentation, but it's all about where to put your data after you've actually collected it. So I have a very boring agenda here. Hopefully this is interesting to somebody. But there's a lot of good things in here I'd like to express and show kind of how and what our security team does on a daily basis. So a little bit around the problems with data. What do you run into as you collect data? The different types of processors that we have inside of Graylog. The different things of parsing that we have. Lots of questions around grok and different regex patterns. And then GIM, which is our information model, normalization, and kind of how logs flow through Illuminate, which is our visualization side of Graylog. So starting off here, really, what is the problems with data? So you have a log source, and we can pick any of them. We'll pick a firewall, for instance. We have a Palo Alto firewall. It's what do you do? How do you identify this log, and where do you get it from? So as that log message comes in, you need to tag that data somehow. You need to say, this is coming from a Palo Alto firewall. That's important for later on, which goes into the second step, is how do I format this data after I get it? I need to understand what the device type was to understand where to stick the data once I gather it. And then really, what do you do when you classify this data? How do I want to make this log easier to search, easier to store, and also interact and work with all of my other devices that are already querying my Graylog infrastructure? So here's a little map that's, I think it's out on our docs site, but it does describe how does data flow through Graylog. I'm going to skip over section 3 completely. I think Aaron did a great job talking about Elastic and all the different shard problems that there are out there. I'm going to focus more on section 2, or the enrichment layer. But there was one thing I want to talk about around collections and inputs. And really, that's where a lot of the initial data is collected. So if you think of a syslog feed from that firewall that you're getting, your Palo Alto device or an ASA device, it sends that data in, and at collection point where you have that input, the codec is ran. What that is doing is decoding the packet off of the wire. So that comes in with a header around it. It's wrapping the syslog header protocol around it. It has to tear that back apart to get to that raw log message. And that raw log message is what we need to kind of continue down the enrichment process. So once it runs the codec on that, it then puts it into our buffer, which then you can go ahead and pull out of that and run the different enrichment streams on that. So once you get past the input side, it goes into the enrichment phase, which is then where we're going to talk a lot about the pipelines and how messages are processed and formatted and then enriched as well. So next comes the processing order. And this is really how is Graylog going to take that after that codec enrichment or decryption and run it through the different chains. So there's 3 main ones that we have. And the third one there is the brand new one that came out in 4.2. So the first one is the message filter chain. This is probably the oldest one that we've had at Graylog. It's responsible. You can set static fields kind of on your input and say, hey, this is a device type of Palo Alto if you want to do it that way. You can also run any extractors that you'd want on your input itself. And this was the old method of pulling off things like SSH logs. You want to pull off a username or you want to pull off a specific IP, you could use that through the filter chain. The new one that we have that has a lot more functionality is the pipeline processor. If you guys have played with this one, there's its own regex language, or sorry, its own language of how you write processing pipeline rules, but it's very powerful. You can do a lot of stuff to this. Manipulate the messages, you can filter them down, you can drop certain parts of those, and you can also do enrichment through different thread intel feeds or different lookup tables that you might have on your Graylog instance. And the third one that we have there is brand new in 4.2, but it's the Illuminate processor. We've taken a lot of the functionality from the pipeline processor, added additional functions in there, such as route to pipeline. For one example of migrating data around without having all of the different streams that you need, so we can bypass the stream itself on how we process logs. And then we also have this running first by default. So you can change your order, and I have a little picture of it down there. But the idea of what the Illuminate processor will do is as logs come into Graylog, and you use our new Illuminate installer pack, it'll actually pick those logs off of the wire by whatever identifier it might have, such as Palo Alto. You can find that specific field, and it will go ahead and process that behind the scenes. Now, the difference of how this works compared to the pipeline processor is in the old way, the pipeline processor, you could go in there and you could see all these rules. What we're trying to do is take all that burden off the end user. The Illuminate processor is done by just our content pack system. You upload the new content pack, everything behind the scenes is done, your data comes out on the other side before you even see it in a pre-formatted fashion, which then, of course, integrates into all of our dashboards, it integrates into our anomaly detection system, and integrates into all of our outputs that we might have as well. So extractors, regex, and grok, oh my. I guess it kind of plays into Aaron's wizard behind the scenes thing there too. So the extractors themselves, what are extractors? They're based upon the input itself. So if you have a syslog input, the extractor is going to run, it's going to look at that message, and it looks at every message coming through. That is the one downside around the extractors, is anything flowing through that input, the extractor will look at. Now if it matches or if it doesn't match, doesn't matter, it still executes on each log. But it's going to go ahead and run on that message and then pull off additional fields, such as the username. You can tag that in. You could also run something like a JSON parse, or if it'll break that apart if it's a JSON log coming in. Now, one downside of these is you cannot use these on forwarders. The extractors, we recommend not using them on forwarders, because of the way that you can't tag the actual logs. So a lot of our Illuminate content that we've been creating have had tags on that. So you could say this is a Cisco Meraki log or something similar to that. Well, that functionality is not based on forwarders. So we're migrating off of that and moving that more into the pipeline structures of using regex to uniquely identify each message and then putting the tag on it there. Now, regex is probably very familiar for most people. There's all kinds of different formats of regex out there, but it is a very powerful parsing mechanism. You can selectively pick different things out, pull those log messages off in different patterns, as well as different capture groups, and then save that and enrich your message as it comes in. This can be very complex, though, and if you don't get your regex exactly right, it can be very expensive and slow down the entire Graylog instance. So there's a lot of things I want to talk about here in a little bit that kind of help you with your regex creation. And then grok, and the best way to describe grok, because it took me a while to actually understand this myself, is just easier to read regex. So each grok statement is a pre-built regex behind the scenes, so you can call something like IP instead of actually parsing out, /d/d/d for the different digits in the regex. But this then does you easier use of creating the parsing rules by just calling a regex name that you know instead of reusing that same regex pattern. All right. And then don't forget the functions. So in our pipeline processor, we have a bunch of powerful functions that we can use. I have a lot of those listed up there, but the has field. The best thing to use for functions inside of our pipeline processor is how do I look for specific data, as well as how do I exclude data I do not want to parse and process. So using something like the has field on that first one, you can say if this log message has a field called username, I'm going to continue processing that message. The good thing about this as compared to extractors on the previous page, if it doesn't have that field, it's dropped out of the actual processing. It does save on CPU cycles and time. So the better way that you can identify that message and then filter out what's not supposed to be processed is ideal, so you can expand your installation, have more logs flowing through it at a very safe and minimal speed from the CPU. The other ones that we have there are the lookup functions. This is great for enrichment of data. We can take any of the fields that we have and take that, let's say, an IP address and use it against a known lookup table. On the previous one, I was talking a lot about watch lists, and this can be something for that too. We could use a pipeline rule, so as log data comes in, let's say user feeds, we can say, is this part of a user that was recently terminated or let go? And we can use that as part of that watch list integration. The other thing really to use, and I won't go through all these, but the abbreviate function on the contains. So contains is a function, and contains is essentially a regex or a search across the entire message. It's very expensive. So if I say, does this log message contain the word Nick, it will look through the entire log message for my name. Now this can be, if it's a very short message, if it's from a firewall, that can be fast, and that can be great. If you get really long Windows messages that are up to a K in size themselves, going through that entire message for hundreds of thousands of messages a second does take a lot of processing power. So we can use the abbreviate function before this and actually say only look at the first 50 characters or 70 characters. It does speed up using all the functions inside of our pipeline processor. And then what we want to do as well is we want to use a lot of these functions before we start getting into the expensive regex or grok patterns. So if we can start filtering out, like I was mentioning before with the has field, and say if this doesn't match a certain characteristic, let's drop that log message out. Drop that log message out. And then we don't have to go through the whole processor. Okay. So let's make an example of this, because this is what everybody really wants to know, is how to parse logs. I can tell by everybody's excitement. All right. So this is a log from a normal Apache log system. So I'm going to go through, and then I want to create a little bit of regex. This is actually using Grok as well. But I'm going through, and you can start to see each individual field. Let me look for the client IP addresses, which is the first field there. And then we're going to look for the user ident and authentication, and those are just dictated by the little hash marks. So after we get our nice regex there, this works great. We start dumping logs through the system. Everything's getting parsed. Then what happens is a log message like this comes in. And you'll see it's about the same, except there's some more stuff on the front of it and the back of it. Now, you'd think that this regex would not work, or this actual pattern, Grok pattern, would not work, but it does. It would still parse the logs the same way. It would find it off, but the problem is that the speed at which this is done is much longer. I'm sorry, it's much slower. It's much more expensive to the CPU to match this log versus the first log on that same regex pattern. You can get around this by using anchors of that data, and there's an example there. It's probably a little bit hard to see, but at the very beginning of that, I put a little caret symbol in front of it. So just by anchoring that, what it's doing is it says start here at the beginning of the message. If the first part of that message does not equal IP or host, it will fail, and the next message will fall off. So using this regex, the first log message would flow through, it'd be parsed correctly, the second message would then error out and not get processed. But it does save all the computational cycles of actually processing that log message. So how much am I actually saving by using those? So if I look at this here, it's the same one that I had there. There was 10,000, I think, roughly messages that they jammed through as a speed test. But if you don't use the anchors, even a full match, you get around 25,000 messages per second. Again, if you use anchors, it matches the same. But the real key there is where it fails to match the starting of it. You can see before it was down around 500 to 1,000 messages, and now we're way up in the 80,000 message mark. Just by having that anchor speeds up the entire processing chain dramatically. Again, if you're a very small customer, if you're the 5 to 10 gig, that's probably not a huge issue, especially since hardware's pretty cheap these days. But when you start to process hundreds of thousands of messages a second, a small regex change like this can make or break your entire system. So let's go into a little bit more of what to do and what not to do in regex and Grok. So again, anchor your expressions. Again, this is that little caret at the end. It's the $sign, or the caret at the beginning, the $sign at the end of that message. You want to also include quantifiers. So if you know how many you should be looking for, let's include that. If you know exactly what, if it's always going to be a digit, you're going to have 3 of those, let's include that too. Let's not just let it expand to exponentially. And then be specific on what to match or what not to match. The more specific you are, the better the regex engine matches, and the faster it will be. If you guys are familiar with regex, there's also something called greedy searches. And greedy searches start looking at data till the end of an actual parsing line. So it'll go through the whole log message, match it all, and then start working backwards until it finds exactly what you're looking for. Greedy matches can also match the wrong thing. So if you start parsing your logs and you're getting multiple fields inside of one metadata field where you expect it to be, it could be because you have a greedy search. Also use the star sparingly. Star is a wildcard. It will match unlimited anything until it kind of runs into the next character it's looking for. So if you have a star, it will match the full line by default until you put some other type of character you're looking for there. So use that as infrequently as you can. And I briefly mentioned before, but also make sure you use very limited back tracing functions. Again, that's the one that goes to the end of the message and works backwards. It constantly is adding more and more CPU cycles to do all those searches. So again, I have the same log message at the bottom there. This is just a different weblog message, and then 3 different regex parsing methods below that. They all work, they are all the same, but the speed at which each one matches is dramatically different. So that first one is how I used to start off writing regex. I knew I wanted 2 different things out of there. I made 2 parameters, and I ran it, and it worked. It was great. You got the log data, it came in Graylog, and it sounded wonderful until you put it in production, and then everybody's system blew up. Now, you create the second one there and you get very defined. So now you can start to say, well, if this log message begins with a 1 or a 2, which is that 12 in a bracket. So that log message has to start with 1 or 2, otherwise it fails. So that does speed up the entire process. If a message comes in with 0.8 in the beginning part and your years at the end, it will just fail that log and it won't go through the rest of the expensive regex. Now with that, some of the different metrics that we had, looking at the worst regex up at top there and dumping about 1 million lines through that, that would take about 10,000 milliseconds or 10 seconds for 1 million lines of logs. If you go to the very bottom one, the most descriptive regex that we have, and of course bigger is always better, so the bigger the regex, usually the better performance you're going to get. But with that, it went down to just 240 milliseconds. So a dramatic difference on non-matching logs. Again, non-matching means that it wouldn't normally capture at the very bottom one. Now, the matching logs, though, even help out a lot too. So the top one is matching, and so is the bottom one. But the top one took an average of 1,700 milliseconds to do it, where the bottom one, 17,000 milliseconds, where the bottom one took 4,700 milliseconds. So again, a dramatic increase even on matching rules. So again, we've did all this parsing. Now, where do you stuff this at? Besides the obvious reason. The first thing, and this was actually a question brought up, I think, on a previous talk, actually probably mine this morning, but is where do I find this schema? I mentioned it previously, and we've been creating this over the past year and a half. So if you go out to schema.graylog.org, you can see our schema information model out there. We call it GIM, or Graylog information model, but it's how are we mapping these different fields in there. We went through and looked at many different log sources, such as Windows devices, Linux devices, firewalls, and then we create individual fields as needed for these. So again, this is an ever-living document. It's going to change as we parse and categorize more and more log data. But it is out there for you guys to reference. So if you're at home and you want to write regex rules and you want to map them to a specific field, if you use our format on this, eventually if you ever start using some of our content that we create, all your data will already be in the right format and it will pre-populate all the dashboards that we have. Doing it on time. We're also, if you look at this, the field name is actually the name that we're having. So in this case, let's pick on source IP. We'll say source IP is the name. We can put the field in there. If it's either an IPv4 or an IPv6 address, we'll put that in the field. And then we do give it a field type. This is very important in Elasticsearch. So as you're storing that data in there, you want to know what is that type behind the scenes. So you don't want to stick an IP address on a keyword field because you can't do different things with it. You can't parse them the same. You can't do ranges on longs or digits if it's a keyword field. So if you want to do, if you take a port number, for instance, and you stick that in a float or a long value where you can actually do ranges, you can then say, I want anything greater than 1024. But if you stick that same port number in a keyword field, you cannot do that aggregation. You just have to search for the exact phrase or word itself. We also have an idea of derived fields. So sometimes you get a log message that comes in, maybe it has a source host name, or maybe it has a source IP, but it doesn't have both. What we can do is actually summarize both of those down into source reference, so you can have one specific spot to search. So if you don't know exactly which field it's in, you can search on this field, and it will find all your log data, no matter where it was at. All right, so I did briefly mention on the index templates that we have, but we are predefining all those fields for you ahead of time. So if you install Illuminate, if you go through our our new processing engine and our new Illuminate installer, we will install these index templates automatically. They are mapped to each individual index template alias. So that they have a prefix on the index, and for an instance, it could be like Bob, and we map to that one. And as we have index rotation happen, we reapply the template, so any log coming in with username is already in the right keyword field. We also put different analyzers on this data. One of the biggest problems that you have is the way that the log data comes in. So sometimes you can bring in things from a Linux box. And it could be that my name is Nick, because obviously Linux is case sensitive, so it's all lowercase Nick. Well, if in Windows I type capital N, it doesn't matter to that as much, but I have a capital N ICK. But if I did a search without an analyzer on there, lowercasing it all, if I searched on the word Nick with a capital N, I would not see the Linux side. I'd only find my Windows logs. So what we do is we lowercase all of the fields with username. So that way you can search on one and it will find either variation of those, uppercase or lowercase. We can also do aliasing on this. So as we need to add in new metadata fields, but you want to reference the old one, we can create aliases for your different data in your indexes, as well as do things like path analyzers. I think Abe's presentation before was a lot around finding malware or things that might have happened. He had some process execution in there. Sometimes you just want to find a specific folder in that path, or maybe this specific file. Well, as we have the path analyzers in Elastic, you can then search on one of those fields and it will find it for you. So you don't have to understand the entire path to search for your data. So that is in the schema, but can we make it easier? Because nobody wants to do anything. That's a lot of repetitive work. It's very hard. It is very time consuming. So we've come up with normalization as well. So on top of just parsing your data out into known fields, let's also put a normalized tag on that. Hopefully you guys can see that in the presentation there. I try to break out a few of them. But if we look at the fourth column, or fifth column over there, there's one with starts with a logon name on there. And it's called our event type. So as log messages come in, we tag them with a 6-digit code. So if I look at Windows events, it could be 4624 is a successful logon event. Well, let's tag that with 100,000. And what that does is as it goes through the rest of our processing pipeline, it hits our functionality for the normalization and says take 100,000 and attach 3 new fields to that. And you attach one called logon, one called authentication logon, and one generic event category called authentication. This is how we're classifying data. Now the benefits of doing this is when you create dashboards like Abe has shown and Jeff has shown as well, you can see these dashboards out there, but you can do summarizations of a lot of data quickly. Again, you're doing hundreds of thousands of messages a second. You don't have time to go through each one, but you want to know at a very broad stroke how many of these are authentication. So now I can search on event category for authentication, and it will gather all the logs. And again, this is going across all different types of sources. So I can map my logon event from a Windows to 100,000, as well as a Linux box, as well as my SSL VPN that I'm remoting in because everybody's working from home nowadays. And you still get that same authentication logon message. It helps you create alert rules as well. So if you start creating correlation rules, instead of looking for a specific event name or number or a specific format of that log, I can just create a correlation rule that says, give me 5 successful logons in a row within 20 seconds, because that seems awkward or abnormal, right? So create me an alert on that. Makes the alert rules more universal. So with all this data, is it already done? I did mention Illuminate before. We came out with Illuminate 2.0 again this week, last week with the 4.2 release. But we're doing all this behind the scenes for you, so you don't have to take your time, because this is a lot of time and a lot of effort and a lot of thought going into how are you going to design all this. So we do the parsing, the enriching, the normalization, as well as give you probably what most people want to see is all the visualization of this data through dashboards and alerts out of the box. So I wanted to talk through a little bit of how we're doing this on the backside to hopefully explain to people. I've had a lot of questions asked, like, how are you guys actually doing this? And if I wanted to create this on my own, how should I be creating my own? Maybe you guys have a Synology NAS that we don't have support for yet, and you want to create your own parsing rules to get that in there. So the first one is, how do I route messages? With Illuminate, we're looking at the all message stream. So as every message comes into Graylog, it by default flows through the all messages. So we're looking at that stream in real time. We try to keep the message extraction rules in stage 2 through 9, if you look at the stages themselves, and you want to be very selective on what you're looking for. Sorry, I'm getting close on time here. I want to be very selective for what we're looking for. So I'm going to match that on the regex filter, then pull it off to the next stage. And that comes in and into normalization. So this is taking that log message, applying the normalization category code possibly, as well as breaking off the different fields. So taking and putting the right destination IP in the destination _ IP field. And then we want to go through the entity enrichment. So do I need to look up that IP because it's a non-internal, non-RFC 1918? And do I need to map that somewhere in the world? We can do that through geolocation, or look at the AS processing, or maybe even want to look it off maybe a CMDB data source. So you can start saying, hey, this is actually my VP of finance, and I can tag that in the log message at processing time. And we've also came up with a custom reserved area too. So you guys have, if you want to do any pre-processing of that, you can put it in stage 0 through 1, and then that would help with you guys rerouting your logs before they get to Illuminate. And the main goal of all of this is to turn logs that look like this, which you can search through, into something very usable like this. Dashboards that have been shown by the previous folks, but seeing very quick representations of different visualizations around. As well as you want out-of-box alerts. So as part of our Illuminate content, we're trying to create more out-of-the-box alerts. So you guys can enable these if you see fit, if you want to look for something like multiple account locks out or password spraying detection. A lot of these we're trying to tie to the MITRE framework as well that looks for those TTPs. And that's it. I want to thank everybody.